Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, in this episode of Keam Crash Course, we're going to be looking at some sample questions from the subject Mathematics. So let's start off. Here's our first question. If A is the set 1, 2, 3, 4, 5 and B is the set 2, 4, 6, then find the value of A minus B. So what's A minus B? A minus B here stands for elements in A, but not in B. So technically, A minus B is subtracting the sets 1, 2, 3, 4, 5 with the set 2, 4, 6. So we will have a new set which will have elements from A which are only present in A and are not present in B. Now if you look at A and B, you can see that the numbers 2 and 4 are present in B, and they're present in A as well. So they'll be removed from the set A, and 6 would not be added because it's in B, and it's subtracted off. So therefore, A minus B is the set 1, 3, 5. So option C is the right option. Option D is basically A plus B. D is basically A union B. Option E, option E, B, and A are correct because they have 6 in them, or they have 2, 4 in them, which are all elements from B. Option C, 1, 3, 5 is the only set where the elements of B are not present, and that's the operation here. A minus B means elements in A, but not in B. Next question. Let A be a set 2, 3, 4, 5 and B be a set 36, 45, 49, 60, 77, and 90. Let R be the relation that is factor of from A to B. So basically, element in A is a factor of an element in B. We need to find out the range of R. So, what is the range of the relation R? The range of the relation R are numbers in B that have at least one factor in A. So let's look at each of these numbers. 36 is 9 times 4, so you have 2, 3, and 4 as its factors from A. If you look at 45, it's 9 times 5, so basically you have 3 and 5 as its factors. 49, however, is 7 squared, so its factor is 7. 60 is a number which has 2, 3, 4, and 5 as its factors. So all of these numbers in A are a factor of 60. So let's look at 77. 77 contains 7 and 11 as factors. 90 has 2, 3, and 5 as its factors. So, as you can see, 49 and 77 do not have any factors in the set A. So therefore, the range of the set will not contain 49 and 77. The other numbers do have factors in the set A. So therefore, the range of R is option B, 36, 45, 60, 90. Option A is incorrect because it only says 60, but 36, 45, and 90 have factors in A. Option C, 49, 77, these are the numbers that do not have a factor. Option D also contains 49, 77. Option E is basically the whole set B, which is incorrect because 49 and 77 do not have factors in A. So option B is the right option. Now let's look at this question. Find the real part of e raised to 3 plus 4i times x. Now basically, the exponent here is a complex number, and this complex number will have real and imaginary parts. Now basically, real numbers, imaginary numbers are those that contain an I in them. I is under root of -1. So roots of negative numbers are considered imaginary numbers, and the other numbers are called real numbers. A combination of real and imaginary numbers is what we call a complex number. So let's look at the number that we have, the complex number that we have. it is e raised to 3 plus 4i times x. Now, according to the laws of exponents, 3 plus 4i, e raised to 3 plus 4i is the same thing as e raised to 3 times e raised to 4i. So the number that we have can be taken as the product of e raised to 3x and e raised to 4ix. Now, we have e raised to an imaginary number. So this, according to Euler's formula, can be written down as cos of the x value, which is 4x, plus I times sine of the x value, which is 4x. So e raised to 3 plus 4i times x becomes e raised to x times, in the bracket you have cos 4x plus I sine 4x. Now, the number in the bracket is a complex number, and we can differentiate its real and imaginary parts. The imaginary part always has I in it, so therefore the real part of e raised to 3 plus 4i times x is equal to e raised to x times cos 4x. Now, e raised to x here multiplies into both these parts. We don't need to do the multiplication here. We can just take the real term from there and multiply that by e raised to x in order to get the real part of the question. So therefore, e raised to x times cos 4x is the answer, so option C is the right option. Option D here is imaginary. So option D is incorrect. Option E is incorrect because it says 0. E raised to 3x by itself is not the real part, and cos 7x is also incorrect. The right option is option C. Now let's look at this question. If z here equals x minus iy, and z raised to 1 by 3 equals p plus I cubed, then the value of x by p plus y by q whole divided by p squared plus q squared is equal to -2, -1, 1, 2, or 0. Now we know that this is the value of z, and p plus iq is the value of z raised to 1 by 3. So from here you can easily gain the relation that the value of z is the same as the cube of z raised to 1 by 3. So z equals to z raised to 1 by 3 the whole cube. Therefore, from there you can get x minus iy as p plus iq the whole cubed. Now, a plus b the whole cube is a cube plus b cube plus 3a squared b plus 3a times b squared. So this is the, we use the formula for a plus b the whole cube on p plus iq, so we get p cubed plus iq cubed plus 3p squared times iq plus 3p times iq squared. So what we're going to do is we're going to separate the real and imaginary parts here. So we have p cubed as a real part, and if you look at 3p times iq squared, you can see that the imaginary I is under a square, and I squared turns out to be -1. So therefore we have minus 3pq squared also on the real side. Then we have the imaginary side, which is 3p squared times iq, and iq cubed. If you have I cubed, then it's the same thing as I times I squared, which is minus I. So therefore you have minus iq cubed. So this is the value of x minus iy. So from here you can gain the value of x and y. So x is p cubed minus 3pq squared. So therefore from there x by p turns out to be p squared minus 3q squared. Similarly, minus y is equal to 3p squared q minus q cubed. So therefore y upon q turns out to be minus 3p squared plus q squared. So now we know the values of x by p and y by q. which is part of our question, let's add them together. So x by p plus y by q. Now that turns out to be p cubed minus 3pq squared. P squared minus 3q squared minus 3p squared plus q squared. So from here we will get minus 2p squared minus 2q squared. So therefore we have minus 2 times p squared plus q squared. So the value of minus 2 will be equal to x by p plus y by q multiplied with 1 over p squared plus q squared. So therefore the value of the question, that is this long expression, is option A, minus 2. So minus 2 turns out to be the right option. Now let's look at the final question for the day. Let z be x plus iy. It's a complex number such that z plus I equals 2. Then the locus of z is a circle whose center and radius are. So one of the 5 options is correct. We need to find the center and radius of the circle, which is the locus of the complex number z. Now we know that z is x plus iy, so we will plug this value into the given expression. So modulus of z plus I is 2. So therefore modulus of x plus iy plus I is also 2. So from here, x plus I times y plus 1, its modulus is considered as 2. Now, in this particular question, we're going to use the formula for the modulus of a circle. The modulus of a complex number. The modulus of a complex number is written down as x under root of x squared plus y squared. So basically, when we square both sides, we get x plus iy squared as x squared plus y squared. So yeah, let's square both sides. So the modulus of x plus I times y plus 1 the whole squared is equal to 2 squared. So this whole term here can be replaced by x squared plus y squared, which is the same thing as x squared plus I times y plus 1 the whole squared equals to 2 squared. Now, for a circle, we have a particular formula. X minus a the whole squared plus y minus b the whole squared equal to c squared, where a comma b is the center and c is the radius. So we need to now find out the center and radius of the locus of the complex number. So we will have to turn this particular equation into an equation for a circle. So x squared is the same thing as x minus 0 the whole squared. And y plus 1 the whole squared is, well, the same thing as y minus 1 the whole squared. And the value of c is 2. So now that we've got our a and b, we can conclude that the center of the circle, which is the locus of the complex number, is 0, minus 1, and the radius is 2. So therefore, among the following options, it's clear that option A is the right option. Option B is incorrect because the center's coordinates differ. Option C is incorrect because the center's coordinates differ. Option D is incorrect because the radius differs. And option E is incorrect because both the center and the radius differs from the value that we've just calculated. So therefore, option A, 0, minus 1, and 2 is the right answer. So that concludes this episode of Keam Crash Course. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. Now, if you want to get more updates about the math from Keam or other subjects from Keam or other examinations from this channel, then please don't forget to hit the bell icon, which is present below this video. So until the next episode, take care, stay alert, bye-bye for now.